Alright guys, we're here, we're at circuits, last unit, we're almost done. Just have to get through this and then we are on to reviewing for the final. So we're really close, but as I've warned you before, this one most students find is the hardest unit. If you can get over some obstacles, mostly in your brain, then this unit actually isn't as complicated as it might seem at the beginning. Here we go, circuits. So what is the purposes for this first lesson? First, we're going to learn about some different quantities involved with circuits. We're going to look at different types of current flow. We'll see what that is in a sec. We're going to explore some diagrams and learn how to measure voltage and current. There isn't actually any problem solving in this lesson because it's very straightforward. The more complicated stuff comes into the next lesson. But this one, we're going to dive into a lot of the concepts that we're going to be looking at. So current, what is current? Well, current deals with the flow of electrons in a wire. The equation for this is Q over T. So I is your current, Q is the amount of charge. Charge is just a coulomb. Those of you taking chemistry, think about that there's a charge of an electron. T being time, like normal. So the units for current are amps or amperes. You just symbolize it by capital A. So current only flows if we have two things. One, we need a voltage source or potential difference. You'll see me use both of those terms. So something like a battery, something like an electrical outlet. These are voltage supplies. They give basically energy to your circuit. So they provide energy for your electrons to move through your wires. The other thing you need is a complete circuit. So if your light switch is turned off, this means there is no complete circuit. Electrons do not flow. So we can compare a lot of stuff with circuits with water. So if you imagine a wire, so a wire that does a full loop, we can consider this like a pipe and water flowing through a pipe. In order for the water to actually flow through the pipe, there has to be something that pushes the water. Otherwise, it's just going to sit still. And we need that to be complete. If I block off one end of the pipe, it's not going to go anywhere because it doesn't have anywhere to go. That's the same thing with circuits. I need to have something causing the electrons to go, and I need it to be complete. Otherwise, if it's not connected in a complete loop, my electrons don't have anywhere to go. So that is current. Voltage and resistance, these ones are a little bit easier to understand. So voltage being the energy per coulomb given to an electron, basically the energy that you're giving to your particles. The units for voltage are volts. Finally, there's a unit that makes the most sense. Voltage, volts. Hopefully you remember that. Resistance, this is how difficult it is for current to flow through a substance. So wires are created with certain metals, and each type of metal provides a different amount of resistance. The units for resistance are ohms. With all three of these, so voltage, current, and resistance, we can put these together into Ohm's law. And that's this equation, V equals IR. So here's a simple circuit. We've got a battery connected to a light bulb. So if you didn't know with a battery, the part that sticks out, that's the positive end, the other end's the negative. This can power a light bulb. Think about what direction does current actually move in this case. So take a guess, 50-50. You can choose. Well, actually, both of those would be correct. So it doesn't really matter which one. We can either talk about electron flow. So that means the direction the electrons are actually moving. So electrons are negative. So they come out the negative end and go around. They're attracted to positive. That is what is actually happening. And there's also what's called conventional current. And what conventional current is imagining that positive charges are moving through your circuit. So back in the day when they were considering electricity and all that, they assumed it was the positive charges moving before they actually figured out what was going on with the specific atoms. The math and the ideas all work with that. It's just the opposite of what's actually happening. So in Physics 11, we are only going to deal with conventional current unless you're told otherwise. So some questions might try and trick you and say, in this circuit, what direction are the electrons flowing? That's the only time that it might be something different. Next concept is power. So power is the rate of doing work. You've seen this already in the energy unit. We've got power equals three different things, depending on which two you're given. Pretty straightforward. Plug numbers into those. That's not too complicated. And again, the units for power are watts. So here are all the different things we're going to be dealing with in a circuit. You don't have to memorize if I ask for a wire, what's the wire drawing? If I ask for a resistor, what's the resistor drawing? What you need to know is, what do the schematics look like? So when you see it in the diagram, you understand what's going on. So all of these should be pretty straightforward. Straight line is a wire, it carries the current. 2 lines, one big, one small, that's a single cell battery. This just provides voltage. If you have 4 lines, it's a 2-cell battery. It doesn't matter, both of those are power supplies. Note with that, the long end of a cell is the positive end and the short one's the negative. Resistors are these squiggly lines. They provide resistance. I had a university professor, he was very picky. You have to have 3 points at the top and 3 points at the bottom. I'm not that strict with you guys, but for me, that's such a big thing. I always have to do 3 and 3. It's like ingrained in my being. And the last 2 things, you've got an ammeter and a voltmeter. Ammeters measure current, amps, ammeter, makes sense. Voltmeter measures volts. So those are your schematics. You need to know those when you see them in a diagram. There are 2 ways we can connect devices into a circuit. Usually we're going to deal with resistors. Don't think there's many light bulbs, mostly resistors. So we can either connect them in series or parallel. Those are our 2 options. So in a series, we've only got a single path for the current to flow through. Think about series, like a TV series. You watch them one episode after the other, so there's only one path to go through. So here's an example of that. Current comes out the battery, the double cell battery, flows through both resistors and then back. There's only a single path. Notice here, this is a double cell battery and these are your resistors. In a parallel circuit, there's multiple paths for your current to flow. Something that makes more sense would be like parallel universes. 2 universes that exist at the exact same time. So parallel just means you've got options. There's different pathways. So what this looks like would be this, where your current comes out the battery and then it chooses which resistor it wants to go through. We'll get into series and parallel, how that affects different quantities in a circuit next lesson. But for now, you need to know what's the difference between these 2. So in order to measure voltage and current, there's a specific way to do that. I already showed you the ammeter and voltmeter. If we want voltage, we're going to put a voltmeter in parallel. So it'll look something like this. I've got my normal circuit, and then I take a voltmeter and I connect the 2 ends on either side of my resistor. That will measure the voltage that's dropped across a resistor. So that's how you need to do voltage, is parallel. With ammeters, you need to connect them in series. So something like this, we need to make sure all the current is flowing through the ammeter, because once I split to parallel, my current changes. Because imagine the water flowing through a pipe. If the pipe splits, the water splits between those. You don't have all the water going through one. So an ammeter in series, voltmeter parallel. You just need to remember those. This one is a really great multiple choice questions to put on the test. So there you go. That is the big amount of introduction work that needs to happen for circuits. This is all the concept stuff. So there's a few questions with this. They're very straightforward. It's more about drilling in these concepts. And next lesson, we're going to look at how these interact and actually do some math to solve some stuff. This one's from Mission Impossible Ghost Protocol. I don't think I ever really finished all these ones. Not enough time, not enough interest. So this one, you've got Ethan Hunt. He's climbing on the side of a building with some sort of magnetic gloves that work with glass. Or there's something in the glass that's magnetic. I don't know. I didn't watch it, so I don't remember. Watch this, see what you can see. Alright, there you go. With this one, you know, he's got his magnetic gloves that are magnetic towards the windows, which doesn't make any sense, but we're gonna roll with it. And the problem being this. So at this point here, something happens, he falls, and then his arm catches. Now, as you are falling down like that, and the only thing that you've got stopping you is your arm immediately stopping against the window, his arm's gonna rip out of his socket. There's no way you're gonna fall that distance and just catch something with your hand and have your arm still be okay. So this whole idea of like coming to an immediate stop, that doesn't work. And that's going to do some major physical damage doing that. He would either be armless or at least dislocated shoulder. Something like that.